All right, ladies and gentlemen, a NASA spacecraft is scheduled to arrive on Mars in just a few hours. I'm so excited, I can't stand it. Inside Lander will closely study the deep interior of the red planet. Tell us more about it. We're joined by Jim Bridenstine, who is you're the head guy at NASA, aren't you? Are you Mr. NASA? Right, Jim?
Well, thank you. Great to be here.
All right, Jim, we're very excited about this. So the actual getting to Mars is the easy part, but the landing on it, that's the toughest bit?
Yeah, that's right. So InSight is going to approach the Mars atmosphere at about 12,300 miles per hour. It's got a heat shield that will dissipate a lot of that energy. Then it will deploy some supersonic parachutes that will slow it down even more. Then it will release from those parachutes and land with rocket thrusters softly on the surface of Mars. So it's going to go from 12,300 miles per hour down to zero in a matter of 6.5 minutes. And during that time, we won't have any communication with the spacecraft. So this is a big deal. A lot of really capable scientists and engineers have put a lot of work into this. It's been traveling for 7 months on its way to Mars, and it all comes down to this 6 minutes.
Oh, that's so nerve-wracking. It's so nerve-wracking. So you don't have any contact with it. So you guys are just waiting around, huh? To find out what happens, like the rest of us.
Well, it's all done autonomously, and we will get data. We will perceive that the data is coming in real time, but the reality is everything we see will have happened 8 minutes ago. Just because of the time it takes for the signal to get from Mars to Earth. So the signals that we do get will be 8 minutes old, but you're right, there will be a period of 6 minutes where we won't have any signals at all.
Ooh, it's kind of scary to me. Okay, what can InSight tell us? What are some of the things that this thing can do?
So that's a great question. There's real serious questions that we want answered about Mars. We know that Mars used to have a strong magnetosphere that protected it from radiation from space. We know that Mars used to have 3/4 of its northern hemisphere covered by an ocean, and we know that Mars used to have a thick atmosphere. The question is, what happened? What changed about 3 billion years ago that made it this, what appears to be dry and desolate, planet that it is today? To be clear, we know that there's water ice on the poles of Mars. We believe strongly that there's liquid water under the surface of Mars. But the question is, what made it change? And there's suspicion that it could be that when the magnetosphere went away, that the radiation environment pretty much dried up the planet. And so what we want to understand is that actually what happened? What are the other things that can happen to a planet that can make it lose its magnetosphere and ultimately lose its habitability? Here's what we know. We know that Mars used to be capable of supporting life. We're not saying that there was life there, but the capability to support life was at one time there. And now it appears that maybe not so much, although when you have liquid water, which we believe there is about 10 kilometers below the surface of Mars, it is possible that microbial life could still exist on Mars. We don't know. We don't know that it ever existed, but we want to find out.
Oh, that'd be so exciting if you could find. Now, you guys are actually going to be drilling down in it. Are we going to get far enough where we think we could get to the layer of water? And then how big of a deal would that be if you got that?
Oh, no. So what we're going to try to understand is how it's losing heat. The part of the reason that it may have lost its magnetosphere is that the core was molten and it became solid. So we're going to try to understand how is it dissipating heat, how is it outgassing, in other words, how is it releasing methane. We now know that the methane cycles on Mars are perfectly commensurate with the seasons of Mars. That doesn't guarantee that there's life, but it increases the probability that there's life. We're trying to understand ultimately what are the ingredients that make a planet habitable. We know what the ingredients are here on Earth. Are there ingredients on Mars that could make it habitable? Could there in fact be life below the surface of Mars, or quite frankly even on the surface? We know that there are complex organic compounds on the surface of Mars. Doesn't guarantee that there's life, but there could be. The question is, under the surface where it's protected from the radiation environment, could there be life?
All right, thank you so much. We'll be watching it with you. It's going to be very exciting today. Good luck, and tell everybody that we're rooting for them. And let's do this, man. I'm ready to retire on Mars. We need to get this going. I'm getting older every day. All right.
Okay.
Thanks, Jim. See you at the mixer. All right, there you go. Over to you, Tina.
I'm going to write you a letter. Maybe I'll get to Mars by the time you get there.
Carol and I actually had this conversation. I was like, I want to retire on Mars. She's like, good luck with that.
All right, thanks.